Assalamu alaikum dear students, welcome back to math class again. This is Mohammad Abshirkar. In this class I have discussed about properties of absolute value. First property, for all x belongs to real number, modulus of x greater than or equal to x. When x is positive, it is very easy to prove. When x is positive, then these two equal. That's why greater than or equal sign. And when x is negative, then modulus of x positive, and here is negative, so modulus of x greater than x. So that's why modulus of x greater than or equal to x. For all x belongs to real number, modulus of x square equal to x square. Here modulus of x square is positive, and x square is also positive. That's why these two are equal. For all AB belongs to real number, modulus of AB equal to modulus of A into modulus of B. Proof. First case, if we take A and B both are non-negative, then from the definition of modulus we get x when x is positive, 0 when x is equal to 0, and minus x when x is negative. Okay. We also write this definition like as we merge these two conditions at a single condition. Here greater than 0 and with x equal to 0, then we get this. We make these two condition at a single condition non-negative. Okay, greater than or equal to 0, then x modulus of x equal to x, and when negative, then modulus of x equal to minus x. So here a and b both are non-negative, so then from this condition we can write modulus of a equal to a and modulus of b equal to b. Okay, and because here a and b both are non-negative, so their product also non-negative, so here ab non-negative. Okay, and that's why modulus of ab equal to a, because when non-negative, then modulus of x equal to x, and a mod a and b equal to mod b, so modulus of ab equal to mod m into mod b. Okay, now case 2, if a is non-negative, if a is greater than or equal to 0 and b less than 0, that means so modulus of a equal to a, because a non-negative and b negative, that's why modulus of b equal to minus b. Okay, and here a is positive and b is negative, and positive number and multiplication of positive number and negative number is always negative, so and this multiplication is less than 0. Okay, that's why less than 0, that's why this condition, and modulus of ab equal to minus ab. Okay, and we write this like as a into minus of b, and here a equal to mod a and minus b equal to mod b. Okay, so for case 2 our proof is complete. Now if a less than 0, that means a negative and b positive number, then also same from the definition, modulus of a equal to minus a and modulus of b equal to b, and here a negative and b is non-negative, so their product is obviously non-negative. Okay, so their product is obviously negative, and modulus of ab equal to minus ab, because here ab is negative, and we write this like as, and from putting the value of minus a equal to mod a and and b equal to mod b. Okay, case 4, if a less than 0 and b less than 0 both are negative, then mod a equal to minus a and mod b equal to minus b. Okay, and here a and b both are negative, so their multiplication will be positive. Okay, here a negative and b also negative, so their multiplication will be positive, so here ab greater than 0 and ab greater than 0, so from first condition, then modulus of ab equal to ab, and you write this like that, like as. Okay, then minus a equal to mod a and minus b equal to mod b. Therefore in all case, modulus of ab equal to mod a into mod b is proved. 4. Property 4. If x and alpha belongs to real number and alpha greater than 0, then modulus of x less than alpha if and only if x greater than minus alpha less than alpha. Okay, if and only if this is very common word in mathematics, in higher order mathematics. if and only if ইউজ করা হয় তখন যদি এটা হয় তাহলে এটা হবে এবং এটা হলে এটা হবে, দুইটাই একটা আরেকটাকে সম্পূর্ণ করবে। যদি এটা হয় তাহলে এটা হবে এবং এটা হলে এটা হবে, একটা আরেকটাকে সম্পন্ন করবে, তাহলে if and only if ইউজ করা হবে। ওকে, now proof. First let this, and so it is required to prove that this. Okay, first we let that modulus of x less than alpha, then it is required to prove that x is greater than minus alpha less than alpha. Okay, now modulus of x less than alpha, and when x is greater than or equal to 0, then modulus of x equal to x. Okay, so and here less than modulus of x less than alpha, and x is greater than or equal to 0, so 0 x is greater than or equal to 0 less than alpha. Here given that alpha is positive, so minus of alpha is obviously negative, as alpha is positive, therefore minus of alpha is negative. Okay, from laws of the inequality we know that if multiplying both sides by -1, then the inequality will be changed. Less than will become greater than, less than or equal to become greater than or equal to. Here alpha is greater than 0, so -1 multiplying both sides by -1, we get minus alpha less than 0. Okay, so minus alpha less than 0 less than x less than or equal to x less than alpha, so this implies that minus alpha less than x less than alpha. So we take modulus of x less than alpha, then we get minus alpha less than x less than alpha when x is non-negative. Now when x is negative, modulus of x equal to minus x. When x is negative, modulus of x become minus x. Okay, that implies multiplying both sides by -1, you get x greater than minus alpha. Okay, now x is negative, so x less than 0, and alpha is positive. Given that alpha is positive, so alpha greater than 0, that means this implies minus alpha less than x less than alpha. Okay, so both case our proof is complete. Now conversely, let minus alpha less than x less than alpha, then it is required to prove that modulus of x less than alpha. Okay, if x is non-negative, first we take that x is non-negative, so modulus of x equal to x, and x is less than alpha, so modulus of x less than alpha. So our proof is complete when x is positive, x is non-negative. If x is negative, then modulus of x equal to minus x, but x is greater than minus alpha, and this implies that alpha is greater than minus x. Okay, so minus x is less than alpha, then modulus of x less than alpha is proved. Let's do some problem of this exercise. Problem 3. Rewrite the inequalities without absolute value sign. Here the problem: modulus of x minus 2 less than 5. From property 4 we get modulus of x. If modulus of x less than alpha, then minus alpha less than x less than alpha. Okay, so that's why here modulus of x minus 2 less than alpha implies that minus 5 less than x minus 2 less than 5. Okay, now we have to free this x, so adding 2 on the side, so adding 2 on 3 side, uh, left side, middle side, and right side, so we get minus 3 less than x less than 7. So this is so solution set is x such that x belongs to real number and x is greater than minus 3 and less than 7. If we draw the solution set on the number line, then you get here x is greater than minus 3, so mark minus 3, and x is less than 7, so mark 7, and the solution region is this. X is all values, for all these values of x, the modulus of x minus 2 is less than 5. Okay, clear? Another problem 4. Rewrite the inequalities using absolute value sign. Now, given this, and from property 4, we learn about if modulus of x less than alpha, if and only if minus alpha less than x less than alpha. So অ্যাবসলিউট ভ্যালু দিয়ে লিখতে চাই, তাহলে বোথ সাইডের ভ্যালুটা সমান হতে হবে, কারণ ওখানে কি ছিল, বোথ সাইডে কি ছিল, মাইনাস আলফা ছিল এক সাইডে, মাইনাস আলফা ছিল এক সাইডে, কি ছিল, প্লাস আলফা ছিল। আমাদেরকে সেরকম একটা ফরম্যাটে নিয়ে আসতে হবে। সেই ফরম্যাটে নিয়ে আসার জন্য সহজ উপায় হলো প্রথমে যে ভ্যালুটা আছে এবং শেষের যে ভ্যালুটা আছে, এই দুইটা ভ্যালুর অ্যাভারেজ বের করতে হবে। প্রথম ভ্যালু এবং শেষ ভ্যালুর অ্যাভারেজ বের করতে হবে। ফার্স্ট we have to find the average of these two value, first and last value, then you get 7, and subtracting both side 7, you get subtracting 7 on both side, then you get this. Okay, now you get minus 3 and here plus 3. So our format is here minus alpha less than more x less than alpha. Okay, here minus 3, we also get 3. Okay, so this implies that modulus of x minus 7 less than 3. Clear? Now solve 3 and 4 in your CW and submit within 2 days. Thank you.